Okay, today we're doing our second section on distance. We'll have a few more problems, some that kind of repeat what we did, but we'll also be looking at wind and current problems. All right, so let's make our box, and I would like for you guys, pause the recording and see if you can just draw the picture. The little picture of where their starting point is and where they end up at. Okay, pause the recording. All right, so when we do our drawing, it should have been they start at different places. One's faster. And so I'm going to make one line bigger and the other line smaller. Okay? Now, who's the bigger line really represent? Joe. And he's going, what?
6 miles faster.
Oh, yeah. He's not going 6 miles per hour. He's going faster. Okay. So what can we start to... What do we know about the whole thing? It's 44, right? Okay, what can I start to fill in my box? Tell me about the time, because that seems like it's the easiest. Daniel. 2 and 2. Okay, Josh. What can you tell me about the rate?
So for Joe, the rate would be x plus 6.
Or how about R? They're both called R because we don't know their rate. But for Joe, it's R plus 6. Now, do we know Joe's distance? No. Do we know Lisa's distance?
No.
We don't know their individual distance, but what do we know?
The total.
The total distance together. So we have to add another box here for a total. And that would be what? 44. So now what am I putting in that top row, the upper, let's go Zach.
For Joe, it's 2 times the quantity of r plus 6, and for Lisa, it's
2R. Now, what is our equation? Yep, Oliver?
2r plus 2 times the quantity of r plus 6 equals 44.
Okay, you guys finish it up. Pause the recording, and you finish it up. What to do?
Okay, so first multiply the r plus 6 by 2.
I'm going to write 2R plus...
2r plus 12 equals 44. Then you're going to combine like terms. 4r plus 12 equals 44. Subtract 12 from both sides. You get 4r equals 32. Then divide 4 by both sides and r equals 8.
Okay, so if R equals 8, the next thing I want to just make sure, I know I wrote up here, I always want to go back to what is the question. If Joe's traveling 6 miles per hour faster and they meet in 2 hours, how fast was each traveling? So that's what the answer they want it to be. So, Xander, what...
We know that Joe's rate is 6 miles faster than Lisa's.
And so what is Joe's rate?
14.
Okay, because it's 8 plus 6 is 14. And we are looking at miles per hour. And what would Lisa's rate be?
8 miles.
8. Now remember when we did this, what happens if they asked you for the distance? Could we figure that out? Okay, Sarkis?
You plug r into 2 times the quantity of r plus 6.
Okay, and what would I end up with?
You get 16 plus 12, which is 30.
16 plus 12. So how about down here? What is R is 8. So what would it be? That's going to be 16. And what's the other one going to be? Right. 8 plus 6 is what? 28, yeah. So we have the ability to find the distance and we have the ability to find the speed, but we only need these two answers. Do you understand that? And that's going to be careful reading for you guys in how fast was each traveling. Is that making sense to you? Okay. Does this feel any easier than yesterday? You kind of start to get used to them. Okay, wind and current problems. Now, there's a couple things and words that you need to know. When you're looking at a wind and a current problem, so when an airplane is flying through the air, you have to think about two things. Have you guys ever been in a lazy river before?
Yes.
So a current or the water is the same as the air. The same thing kind of happens. The math is the same. The difference is the water versus the wind. So when you're in the lazy river and you're not doing anything, what happens to you? It pushes you. The water pushes you and it gives you speed. And if you are actually moving your legs on your own and walking in the water and it's pushing you, you go really fast. Kind of like on those walking escalators. When you just stand there, you go pretty fast. It's pushing you. But when you walk and it's pushing you, you go double fast, triple fast, whatever. It's really fast. So the same thing happens with the wind. The speed of the plane plus the speed of the wind. So there's two things you have to think about. In the wind, A, the speed of the plane, and B, the speed of the wind. In the water, you have to think about A, the speed of the boat or the jet ski, and B, the speed of the wind, the water, sorry. Now, when the water in the lazy river is coming from behind me and pushing me, it makes me go what? Faster. So I'm adding speed with the wind, with the current. Does that make sense? When I'm going against the current, what's happening? It stops me. It's slowing me down from the normal speed I would normally be going. So when I'm in the wind, the same thing happens, only they have special names. When I'm going into the wind and the wind is hitting my face, what's it doing? It's pushing me back, and so we call it a headwind. So I'm losing speed. Okay, but when the wind is from behind me, we call it a tailwind, and it is pushing me faster. So you have two speeds, the speed of the plane and the speed of the wind. If it's a headwind, it's being subtracted. If it's a tailwind, I'm getting wind speed added. Does that make sense? So in this case, we're going to call P the speed of the plane. In my problems, I like you guys to use R for speed. So you know it's the speed of the actual vehicle. And we'll call W the speed of the wind. Okay? So now we've got our problem. What am I comparing? And what is implied? Let's draw the picture. Pause the recording and draw the picture of what's happening. Okay, tell me what is implied here with this diagram. Olivier.
I think it's kind of like a race diagram because you could be racing the time of the first trip and then the return trip.
Okay, other people? Mary?
Same distance is applied.
Same distance is implied. Why? Because I'm going there and back. It says return trip. Return trip implies the same distance. When I go to school and I come home from school, isn't it the same distance?
Yes.
So what's happening is I'm starting and then I come home. So that the distance is implied. Now I could write a D, or if they give me something, I can write that as well. But the same distance is implied. So let's go. We're going with wind. We'll call it wind. And we'll call it against. Just differentiate. It doesn't matter what you call it as long as you know. Okay, so what is the time with wind? Josh?
It's 4 hours.
4 hours. And against?
5.
Okay. And then, do we know the distance?
1,200.
1,200. With wind, against wind, or together?
Together. No. For both of them.
For each one. It's 1,200 this way, because it says it's 12. A light plane flies 1,200 miles with wind in 4 hours. 4 hours. And then it comes back. 1,200 miles in 5 hours. Right? So they're both individually, we know their distance. Now, what are we going to call this? Do we know the speed of the plane? So what are we going to call it? P. Normally call it R for your homework, but for here we'll call it P because that's what my PowerPoint does. And then what am I doing with that wind? What is that? What about the wind speed? Yes, Daniel.
P plus the W.
Plus the W. What about against it, Rashmia?
Against would be just P.
P. But it's not only, it's not like there's no wind, it's pushing you the other way.
P minus.
Yes. Do you guys understand?
Yes.
So our two equations are as follows. They're 4 times the quantity of P plus W equals 1,200 and 5 times the quantity. Now in this particular case, we can simplify this. You should be writing as we're going. We can simplify. How could I get rid of the 4? Andy, what can I do to the 4? Yep, divide both sides by 4, and we are left with P plus W equals 300. What do I do next? Anybody? Trent? For the other one. How do I get rid of the 5?
You divide both sides by 5.
And what do we end up with?
P minus W equals 24.
Good. Now, I've got it perfectly set up so that I can do elimination. Why? Because I have a positive and a negative. And if I do that, then we'll have 2P equals 540. Divide by 2, and we get P is equal to 270. Now, what does that mean, P equals 270? What does that mean? Yes.
The plane speed without the wind in general is 270.
So this is 270, just without wind. And it's 270, was it miles per hour?
Yeah.
Okay. Now, how do I figure out the wind speed? Jack.
For the wind speed, you subtract or add, for the wind speed, you plug the 240 back into the equation and then...
240?
No, 270
270.
back into the equation.
And I'm going to do this equation because this equation is the same as this equation. Right?
Yeah.
It just did the same thing, property of equality. It's still equivalent. So it's really like the original equation, it's just simplified. So I'm going to do 270 is the plane speed minus the wind equals 240. Subtract 270, subtract 270, and I get negative wind equals negative 30. So wind is equal to 30. So the wind speed is 30 miles per hour, and the plane speed is 30 miles per hour. Now we have the ability to also find the actual speed the plane was going with wind was 270 plus 30 would be 300, right? And this would be 240. Does that make sense? Those are actuals. But what is it asking me? In this case, we always go back to the original problem and we look at what they ask. It's usually towards the end. So make sure, find the speed in still air and the speed of the wind. Yes, Joy. Oh, okay. Yes, Gavin.
When we simplify it, it kind of gives us the answer.
Mm-hmm. All right, let's try another. Ready? I don't know if this is, okay, we have 15 minutes. Okay, we can do this. All right, let's try this one, and let's see if you guys can do this one on your own. I'm gonna stop you at like 1 minute increments, and we'll check. Okay, so, no, it's not. Okay, so I want you to draw your diagram now. Go. Okay, what does our drawing look like? Train leaves Sherman Oaks traveling east at 80 kilometers per hour. An hour later, another train leaves Sherman Oaks on a parallel track at 120 kilometers per hour. How far from Sherman Oaks will the train meet? Sabine, what kind of diagram am I drawing?
A race.
A race. So we have one that starts and it leaves, and then we have another one that starts and it leaves. And we want to know how long will it take for it to meet. Right? So let's call this, how are we going to differentiate it? Let's call it the first and the second, or the slow and the fast. Slow. And this is first. And this is fast. And this is the second train. And how am I labeling Trent?
So for the slow, the rate would be 80, and for the second,
Okay, it's 80, and the other one would be
120.
120. Okay, now here's where it gets a little sneaky, is with the time.
So for train 1, it would be T time,
T,
and the second one will be T minus 2,
T minus
T minus 1.
minus 1, because he's traveling 1 hour less. Now, do we know their distance? But what's implied?
They meet at the same place.
They meet at the same place. So this distance is the same as this. Distance and distance. If I don't know it and it's the same, I can use the same variable. So now what are my two equations? Let's go with somebody I haven't heard from. How about Sean?
80t equals D.
Mm-hmm. And the other one?
120 times the quantity of T minus 1.
Good. And now what can I do? Michael.
So, so take 80t and put that.
You mean substitute
Substitute.
that.
Substitute D for 80t.
Good. Okay, so I end up with 120 times T minus 1 equals 80T. I'm going to distribute. I'm subtracting 120T. I'm subtracting 120T. Negative 120 equals negative 40T. Is that right?
Yep.
Divide by negative 40. Divide by negative 40. T equals positive 3. And it better be positive 3 because we can't have negative time. So, what is the question asking? How about Connor? What is the question asking?
When will the trains leave?
What?
The question's asking us when the trains will be.
Not when. No, it's not asking when.
Oh, how far away from Sherman Oaks?
But what did I find here?
The time after they meet?
Did I find what they need? No. I found the when They're asking the where. Do you understand that? Okay, so we do know that the time is 3 for the slow one, and how much time did it take for the slow one, for the fast one? 2. Yep. Because 3 minus 1 is 2. But now, what is my distance, Connor?
The distance is 240.
240 for the slow one. And what else? 120 times 2? 240. I'm just multiplying across once I know that. And it should be, as well as it should be, the distance should be the same. Does that make sense, guys? Do you understand how sometimes we find a variable and it just helps us to find the answer? It's not the actual answer. Are there any questions? Yes.
I get why the first train, the distance would be 240.
Because this is 2 minus 1. I'm sorry, 3 minus 1. T is 3, right? 3 minus 1 is 2, and 2 times 1, 20, right? All right, I'm going to move on. Can I erase? Okay, let's try. You want to try?
Sure.
Yeah, motorboats. It should be motorboat. We want to try this one on your own? Let's pause the...
It's motor.
Okay, pause the recording and try. We will say it's motorboat.
It says M-O-T.
Shh. You're working. You're working. How am I labeling the left side of my box? Michael?
With the current and against.
Okay, so I'm going to write with current and against. All right, let's see where you guys started filling in your boxes. I drew a quick little diagram. We're going downstream and upstream. Return trip implies what?
Same distance.
Same distance. So what can we fill in? A motorboat took 3 hours to make downstream with the current. They also call this, those are words you need to know too. Downstream is being pushed. It's with the current. So downstream, how about Boeing? Tell me about where I'm putting that 3 hours.
For 3 hours is the time, so you just put it in the time box.
First row or second row?
For the first row.
Okay. So if that's downstream, then this should be upstream is against, right? With a current of 6 kilometers per hour. So how am I writing that? This time I know the current. I know the current. Olivier?
Down current would be 6, but we don't know.
The current is the speed of the water. What are we missing, Olivier?
Right?
Good. So how am I going to show downstream current?
We would put it right on
Michelle? Loud so the room can hear.
R plus 6.
R plus 6. And then the return trip against the same current took 5 hours. What is the rate against it going to be? R minus 6. And the time here is going to be
5 hours.
5 hours. Find the speed of the boat in still water. So now what am I going to do? Because last time I had the 1200. So what can I do? Mary?
You can put that for the distance area. You can just put D's because
D.
we don't know the
Because we don't know them and they are the same. So my two equations are D equals, let me do this. How about this? Watch. 3 times R plus 6 equals D. And how about if I just do D equals 5 times R minus 6. And now we can just substitute right there. 3 times R plus 6 equals 5 times R minus 6. 3R plus 18 equals 5R minus 30. We're subtracting 18, subtracting 18. That didn't help. I left myself negative 48. I guess I'm going to have to subtract 5r, subtract 5r. I end up with negative 2r. Divide by negative 2, divide by negative 2. And r is equal to what? 24 what?
Kilometers per hour.
So, find the speed of the boat. So, the speed of the boat, the rate of the boat is 24 kph. Okay, questions? How are these feeling? Okay, you can stick around for another example, but I think you pretty much have what you need. We can do this one together. So, this time they're talking about a jet ski, and you guys can try this all on your own. So pause the recording. I'm going to put the answer. Try this one on your own, and I'll put the answer up. Okay, so we are going down the river 14 miles. We're coming back the river. It says the return trip, so it's implied that the distance is the same. So where does that 14 miles go?
That goes in the distance.
Good. Okay. What am I placing? Where am I placing? What can we put for time? Ansana? 40 or 40. See, this is where 40 out of 60 is what I would do going downstream, which is really 2/3. And going upstream, I want some people to try it with just 40. And I'm going to try it with the 2/3. Okay, and then upstream would be just 1. Now, what is our rate? Going downstream, what do you think we're going to call that? Gavin?
J minus R.
Downstream.
Oh, J plus R. And then
J plus R, because it's pushing us down. Down means you're going with the current. And upstream is going to be?
J minus R.
J minus R. So my equation is going to be the quantity of J plus R times 2/3 equals 14. Right? And the other one is J minus R. Now right away, I'm going to clear my fraction. So I'm multiplying by 3/2 by 3/2. That becomes J plus R equals 21. The other one is J minus R equals 14. 2J equals 535. Divide by 2. Divide by 2. The J equals what? 17.5 what? 17.5 what? Guys? 17.5 what? Miles per hour, mph. Okay? Now, what? That is the jet ski. In this case, we called R, which I really would have called it C. So now I'm going to say 17.5 is our jet ski, right? mph. And now, if I subtract 17.5, subtract 17.5, what do we get? I think I'd put it up here somewhere. It's 5, it's 3, and it's a negative. So R is equal to 3 5/10. It's 3.5 miles per hour. Okay, how are these wind and current problems for you? You can pause the recording. That's it. Tonight you're working on page 384, 1 through 14. Do as many as you can. Maximum time would be 2 hours. If you're burning out, you can walk away a little bit early. I will not collect these till Friday.